Okay, so today we're going to talk about section 1.1, which is just an overview of statistics. So almost every day you're exposed to statistics. For example, you'll see things like, according to a survey, more than 7 in 10 Americans say a nursing career is a prestigious occupation, or social media consumes kids today as well, as more score their first social media. Media accounts at the average of 11.4 years old. So these are both just examples of a statistic. The data consists of information coming from observations, counts, measurements, or responses. Statistics, then, is the science of collecting, organizing, analyzing, and predicting that data in order to make decisions. A population is the collection of all outcomes, responses, measurements, or counts. So a population, when we talk about population, that's going to be the collection of all outcomes. Where a sample is just a subset or part of the population. So oftentimes we won't know the entire population, or we won't be able to maybe ask the entire population, so instead we'll have to use just a sample of the population. So in this example, it says in a recent study, 834 employees in the U.S. were asked if they thought their jobs were highly stressful. Of the 834 that responded, 517 said yes. And so to identify the population in the sample and describe this data set. So the population then consists of all U.S. employees. So that's all of the employees. The sample then consists of the 834 employees who answered the survey. So the sample is the 834 who responded to the survey. So the data then consists of 2 responses. There were 517 who responded yes, and the remaining 317 who responded no, that their job was not stressful. So the population in this case, being all U.S. employees, is very, very difficult to actually get every single employee in the United States to answer a survey. So obviously, that's not what the target is here is then. Instead, we'll break that down into a sample where we've maybe randomly chosen, and we had a bunch of people who did not reply to the survey, but we did have 834 employees that did respond to the survey. So, some more definitions. A parameter is a numerical description of a population. So P for parameter and P for population. So it's a numeric description. So some sort of description that characterizes a population is called a parameter, where a statistic is a numerical description of a sample. So S for sample and S for statistic. So again, this whole section's got a lot of definitions, and that's basically what we're just doing now, is describing the definitions. So the next example says, distinguish between whether it's a parameter or a statistic. Example 1, a survey of several hundred collegiate student athletes in the U.S. found that during the season of their sport, their average time spent on athletics by student athletes is 50 hours per week. So it says that several hundred in the United States. So obviously then that's not all the students. Oops. So So since it's not all of the students, then this is going to be just a sample. Statistic. Actually, I'm going to see if I can get rid of this line. There we go. Good. All right. So again, one more time, since we're talking about several hundred students, obviously it's not every student. Since it's not every student, it would be a sample. The answer, the 50 hours per week, would be the statistic that goes with that. So it's a sample statistic. Number 2, the freshman class at a university has an average SAT math score of 514. So this one can be a little different because we're not talking about all university students. We are talking about the freshman class at a certain university. So in this case, this is doing the whole class. And since the whole class is being averaged, or we want to look at their average, so this actually then is a population. And therefore, because we're looking at the math SAT score, it is a population parameter. So really quickly, let me explain this again. Because it's an entire class at a university, then that is the whole class that's being looked at. Since it's the whole class, it is the population. Now, if it had said that all freshmen, that they were looking at the freshmen in the entire United States, then that freshman class would just be a sample. But because it's not talking about the entire United States, it's just talking about this one university, they are looking at every single freshman in that university, making it a population. So sometimes you have to think a little deeper than just what you might think when you first read the problem. All right, number 3 says, in a random check of several hundred retail stores, the Food and Drug Administration found that 34% of the stores were not storing fish at the proper temperature. So again, we have a random check of several hundred retail stores. So it doesn't say there are retail stores in a state or retail stores across the United States. So it's just a random check of all of these stores. Therefore, this is going to be, again, it's not all stores. And since it's not all the stores, this is a sample statistic. All right, next up talks about branches of statistics. There are 2 branches. The first one is descriptive statistics. And descriptive statistics involves organizing, summarizing, and displaying data. Where inferential statistics involves using sample data to draw conclusions about a population. So oftentimes this is why what we're going to accomplish, because we have just a sample and we want to draw conclusions about a population, so therefore inferential statistics will be used. So, a couple more examples. Determine which part of the survey represents a descriptive branch, what conclusions might be drawn from a study using inferential statistics. So, example 1, a study of 2,560 U.S. adults found that of adults not using the internet, 23% of the households earned less than $30,000 annually, as shown in the figure. And again, with statistics, oftentimes there is a figure that's involved. So, this is then indeed the descriptive And descriptive part of the statistics says that 23% are from households. So 23% are from households earning less than $30,000. We are describing what's happening in this information. So again, if you look at the definition, descriptive statistics organizes, summarizes, and displays data. And that's what we're doing. We're organizing it, we're summarizing it, and then we're displaying it. Number 2 says, a study of 300 Wall Street analysts found that the percentage who incorrectly forecasted high-tech earnings in a recent year was 44%. So, in this case, 44% is descriptive, similar to what we have above. It is descriptive because we are describing what type of information. However, we have a possible inference here that would be that the stock market forecasts are difficult to predict. So we might infer from this that the stock market is hard to predict. And that would be your inferential statistics, where you're actually making an inference based on. So may or may not be true that the stock market is hard to predict, but because 44% incorrectly forecasted it, you might infer that that's part of the problem with working on Wall Street as analysts. All right, and that wraps up our first lesson.